All right, getting towards the end, now we're into gas laws. Starting with question 69. A pressure of 79 millimeters mercury is what kilopascal measurement in atmosphere? Well, first of all, you need to remember that 1 atmosphere is equal to 760 millimeters of mercury and is equal to 101.3 kilopascals. So we just need to do a metric conversion here. 791 millimeters of mercury. If we multiply that by 760 millimeters for every 1 atmosphere, we'll get our measurement in atmospheres. Which is 1.04. Same story to convert to kilopascals. 791 millimeters of mercury divided by 760 millimeters for every 101.3 kilopascals. And that's 105.4. All right, next one. We've got our 3 laws: Boyle's law, Charles' law, and Gay-Lussac. Boyle's law deals with pressure and volume. As pressure increases, volume decreases. It's an inverse relationship. Therefore, we write that equation as the pressure times the volume of the gas in one condition will equal the pressure times the volume in the gas in the other condition. If we were talking about Charles' law, which this doesn't ask, but I'll put in there anyway because it's good, volume and temperature vary directly when we talk about Charles' law. And this is the relationship you would use. Gay-Lussac. Gay-Lussac's law is the relationship of pressure and temperature. It is also a direct relationship and would be written like this. We can put them all together to make the combined gas law. Just like that. One way to remember Boyle's law, Charles' law, and Gay-Lussac's law is to remember this. Good vacationers check passports before traveling. Good vacationers, Gay-Lussac holds volume constant. It's not involved in the equation. Check passports, Charles holds pressure constant. It's not involved in the equation. Before traveling, Boyle's holds temperature constant. Question 71. What is the volume of 15 moles of gas at 23 degrees Celsius and 10 atmospheres? Now we're going to use PV equals nRT. Pressure and volume, this is the ideal gas law. The ideal gas law constant, R, is 0.0821 liter atmospheres over mole Kelvin. That is what you all calculated in the gas lab that we did on the 19th and 20th of April. So we just plug and chug for this one. N stands for moles. We have to remember that temperature always has to be in Kelvin. So we have to take 273 plus 23 for 296 Kelvin. So our pressure is 10 atmospheres. We're solving for volume. The number of moles is 15 moles. 0.0821 is our gas conversion, or gas constant. And then our temperature is 296. Now we just plug and chug. So in order to get volume by itself, divide both sides by 10. 36.5 liters. 72. You have 1 liter of gas at 200 Kelvin and 1 atmosphere. If we double the pressure, what will the volume do? Well, this is going to use PV over T. We have 1 liter of gas. It is at 1 atmosphere and a pressure of 200, or a temperature of 200 Kelvin. We're going to double the temperature, so we're going to now have, we're solving for V, 400 Kelvin, and we're going to double the pressure, 2 atmospheres, and solve for V. Well, if you do that, you're going to end up with 1 liter. That's because pressure varies inversely to volume and temperature varies directly. And if you're doubling them, one of them will have it by 2, the other will multiply it by 2. 73, the temperature of a gas is lowered at constant pressure. How will that affect the collisions between the gas and the chamber? So if the temperature is getting smaller, we're talking about temperature, we're talking about volume, because pressure is being held constant. So this is Charles' law. Volume is going to get smaller. It's going to take up less space. So the word's constant pressure, though, says that the collisions will be the same between the container and the gas. Okay, but that means the container has to get smaller. The space between the gas particles, as you lower the temperature, the gas space is going to get smaller. The particles will contract. The speed will also decrease because temperature is decreasing, so the speed will decrease. STP stands for standard temperature and pressure. Standard temperature is 273 Kelvin. Standard temperature, that's standard temperature. Standard pressure is 1 atmosphere or 760 millimeters of mercury or 101.3 kilopascals. If we have a pressure of 729 millimeters of mercury, convert that. Didn't we already do this? No. We did 791. All right, 729 divided by 760. 0.96 ATM.